In this video, we're going to talk more specifically about what we mean when we say the rate of a chemical reaction. So the rate of a reaction, generally speaking, is just the speed at which reactants are consumed and products are produced. And if we're talking about the rate of a reaction as a whole, that means we're expressing it per mole of reaction, which just means for the number of moles specified by the coefficients. So this is expressed as a change in concentration per change in time. Change in concentration per unit time. Oops, sorry. Change in concentration, there we go. Usually, this is going to be molarity per second. So you will sometimes see this written as molarity over seconds, or expressing exactly the same thing, molarity times inverse seconds. So those two labels are equivalent. On the AP exam, this one is probably actually more common, but you will see it expressed either way in the world at large. So mathematically speaking, the rate of a chemical reaction is often described generically, something like this. So you've seen the delta, the little triangle before, means change. So on the top here, we've got the change in concentration. Remember, the square brackets always mean molarity. Change in concentration. Here we're of A, of what generic A is, whatever generic A is. And delta T would be the change in time. So the change in concentration divided by the change in time is equal to the rate in terms of A. So some other terms that you will see, the rate of reaction is describing the reaction as a whole, but we can also describe the rate relative to one specific reactant or product. So you'll sometimes see the rate of disappearance of something is the rate at which a reactant is being consumed. And that would be one specific reactant. A specific reactant is being consumed. Or sometimes you'll see rate of appearance of something. Is the rate at which a specific product is being produced. So we can relate these rates of disappearance or rates of appearance to the rate of the reaction overall, just using stoichiometry. So for instance, let's say we have the reaction 2A reacts to form 3B. So let's say if the rate of disappearance of A is 0.24 molar per second. What is the rate of the reaction? So the rate of the reaction is always per mole reaction, which just means for 2 moles of A reacting to form 3 moles of B. So for this reaction, 1 mole of reaction is equal to 2 moles of A reacting to form 3 moles of B. So we can do the same kind of stoichiometric conversion that we do with coefficients, but what it amounts to is that we're just dividing by whatever the coefficient is. 1 mole of reaction is equal to each of these coefficients. We take whichever one we need. In this case, it's going to be A. So if our rate of disappearance of A is 0.24 moles of A per liter is the molarity that we're talking about per second. To convert this to moles of reaction, we just need to convert from moles of A to moles of reaction. 2 moles of A represents 1 mole of reaction. So just like any other stoichiometric conversion, that coefficient is going to come into play. And it's always just 1 mole of reaction is represented by whatever your coefficients are. So here we're just dividing by 2. So our rate for the reaction would be 0.12 molarity per second. So this is something that's pretty simple and it comes up a lot, but people tend to forget about this type of conversion, that the rate for an individual reactant or product is related to the rate of the reaction as a whole just by its stoichiometric coefficient.